Morning everyone. In this video, we will be looking at metadata and reification. Okay, so we will be discussing what is metadata, what is reification, and etc. Okay, so in the coming slides. So metadata is the data that actually describes other data. Okay, so for example, from the examples whatever we are seeing, a class definition is a metadata. Okay, so it is actually describing that particular object, isn't it? Okay. Models are inherently metadata actually. They actually describe the things being modeled. They are not the actual things, isn't it? So they actually describe the things that are being modeled. So models themselves are inherently metadata. Many real-world applications have metadata. Okay, say for example, you have part catalogs, okay, which actually describe parts of, say for example, a computer. Okay. You can have a blueprint of a building, okay, so, and also like dictionaries, so of certain applications, of language as well. So many of these real-world applications have this sort of metadata and then way of representing this metadata. So computer languages and implementations also use this metadata heavily. Okay, let's see where they are being used. So think about an example here, something like this one. Here is a best model. So there is a car model. Okay, so the car model has a model name. Okay, and year, from which year it belongs to. It will have a base price and it will be manufactured by a company. Okay, so the company to the car model will be like an association company. Okay. Okay, and then these car models, the car models, for example, can be something like Renault from 2021 model and Triber. Okay, so it will have a base price. Similarly, like say for example, Toyota Corolla from say for example 2009 model and something. Okay, with a base price. So similarly, a Mazda 6 with some year, say for example 2004, with some base price. Okay, so the companies are respectively the same. Okay, so Renault, and then like a Toyota Corolla, Toyota. Okay, and then Mazda. Okay, so this is about the car model. A car model actually describes many physical cars and holds the common data for you. Okay, say for example, the physical car is say for example, the Renault 2021 model. Okay, so the Triber. Okay, so that is the model. But a physical car will have its own serial number. Say for example, its color is cherry red. Okay, and it will have certain options which actually decides whether it is high-end model or something like that. Say for example, whether it has rear end camera, etc. Okay, so this is the one which actually describes a physical car, and then a person actually owns this physical car. Okay, so the car model is actually describing many physical cars. Okay, say for example, the Renault model which I was talking about. Okay, so which actually defines several cars, several physical cars, and the physical cars themselves will have the features. So thus this car model actually holds this common data for all these physical cars. Okay, so in that sense, a car model is a metadata relative to the physical car, and the physical car can be taken as the data. Okay, hope now it is clear. We can actually consider classes as well as objects. Okay, but classes will be meta objects. Okay, so you will be instantiating a class, then you will have the object. Okay, but the classes are not themselves in basic sense they are not objects, but then these classes are meta objects and not real world objects. Okay, in that sense. Okay, these class descriptor objects also will have features, and they in turn have their own classes. Okay, say for example, a class, the details of a class can also be described by another class descriptor object, so which are actually called as meta classes. So now you see this one, there is a meta class, okay, which actually describes this sort of class, and the class is the one which is actually describing the object eventually. Okay, that's the level you can actually see. Different languages have different levels of implementations. Pure object-oriented classes language, something like Smalltalk, will have better features for that one. But as far as our course is concerned, in terms of Java is concerned, Java has this java.lang.class is a meta class, and you can actually use Java Reflection API. Okay, using the Java Reflection API, like you can actually get to know whether a particular class. Of course, you have to get the reference to that class. Okay, using class.forName, and then like you can actually give the exact name of the class, including the package hierarchy. That will actually give you the reference to a class, and from that one you can actually get the information like whether this class is an interface or abstract class. Okay, whether it is an actual class, or what are the attributes in it, what are the methods in it. Okay, you can actually use all that information. Okay, so using this meta class, and in fact actually using this meta class, you can even instantiate an object from that class for that particular class. Okay, so basically like using this meta class, you can actually get access to a particular class. Okay, it's meta information. Using that meta information, you can actually instantiate a class. Okay, if you are really curious about that one, I will leave a reference at the end of the video for how to use the Java Reflection API. Okay, if time permits, like we may be trying in the lab, but then like probably not every feature of Java we can try as part of the labs. Okay, so in that way, like some of the references I will also be keeping in the videos, because now you have enough basics of Java. As part of the labs, we have learned enough. Let's move on. Then let us look at the second concept, which is called reification. Reification is the promotion of something that is not an object into an object. So it is not an object originally. So you are actually promoting it to an object. Okay. Why you do it? Reification is very helpful technique for meta applications. Okay, so we have seen like meta objects earlier, meta classes as well. For meta applications, reification is very good, as it lets you actually shift the level of abstraction. Okay. One occasion where it is actually useful is to promote these attributes, methods, constraints, and control information of an object so that you can actually describe and manipulate them as data. I will show you an example, okay, in 2 slides. So conceptually, reification, so let us look at some examples. Consider a database-based application, okay, database application. So a developer could write code for each application, okay, so that it can actually read and write from the files. Okay, whatever the operations you want to do, he could have written like this operations for reading and writing from the files, and for the whole database, for everything, like you can actually use this code. Okay, for every database operation, so you can basically access the file, read it, write it. Instead, for many applications, it is better idea to reify the notion of a data services, okay, and use a data manager, and then like have common services. Okay, so that's the basic idea. So instead of writing code for every read and write for the files, okay, for every application you develop, you have this sort of data services which you will actually reify. Okay, so you are making them as generic objects. So then a database manager has the abstract functionality that actually provides a general purpose solution to basically to access data reliably and quickly for multiple users. Okay, so this is one of the uses of reification. So an example. Okay, so you are actually having this sort of abstract functionality out, and then like you are defining them. Okay, and then like which will be used by all these different applications. Okay, and let us look at a simpler example. Okay, so as I already mentioned, like reification actually promotes attributes to a class. Okay, think about like this sort of substance is a class here. Okay, substance name is an attribute there. So we are talking here about chemical substances. Okay, but the interesting thing is chemical substances always will have several aliases. Okay, if it is petrol, it is gasoline. Okay, so of course like gasoline is not a simple compound, it will be like combination of several hydrocarbons. So let's think about, say for example, chemical substance, something like propylene. So you call it propylene, so you also give it a chemical name C3H6. Okay, so that means like your substance has several substance names. To capture all these sort of multiple names, you can actually reify the substance name to a class. Okay, you can actually promote this attribute to a class. So then like you have a substance name, of course like it will have a name, and then like you have a many to many relationship between the substance and the substance name. And of course like each of the name is an alias. Okay, so you can have more than one name. Okay, so this is a perfect example of reification. So if your application demands, you can have it. So again, we are still in chapter 4 of object-oriented modeling and design with UML. Okay, so and then like regarding the Java Reflection API, so here is the place like you can actually know about how to use the Java Reflection API. Thank you very much for your attention.